probabilities. And those who took my basic math class, we already learned some basic probability problems. Okay. First of all, let's recall the definition of probability. The problems we're going to study usually are about the discrete data. Okay, you can count the numbers. Okay, so a probability of some event, okay, something, right? We're talking, yeah, is defined by the ratio. The denominator is the number of all possible outcomes, no restriction. Okay, well, it depends, you know. Well, there's when we talk about all the integers, of course, there's a restriction, but then even numbers is more restriction. Okay, so it's a ratio of the number of all possible outcomes, and the numerator is the number of all designed outcomes. Okay, that was under some conditions. Okay. Now here, an event is about counting points in the geometric figures. In that case, the number, when I'm talking the number, usually means the area or the length and the volume. Okay. We will deal with this kind of problems later. Okay. Before probability, right, we study counting techniques. The reason we want to study counting techniques is because basically it's just about counting problems. was a restriction or without a restriction? Okay, if you know how to do the counting, then you know how to solve it. You know how to do the problems here. All right. So let's take a look at the first problem. Okay. Now, if you have answers, and you can post it here. If you don't want to see other people see answers, you can privately post the answer to me, right, in the chat window. Okay, a bag contains six marbles, numbered 1 to 6. A marble is removed from the bag, okay, and without repressing it, just take one by one, okay. A second marble is drawn. Now, what is the probability that both numbers are odd? So basically, you're going to draw two marbles. Okay, when we count, and here's all this counted because you can say this is the first marble, the second marble, right? So you're going to you're going to draw two marbles one by one without replacement. So what is the number of all possible outcomes? Well, the number of all possible outcomes, right? All possible outcomes, we're going to put the two numbers here, right? One by one. Now, if the first marble number is 3, then it's 3. The second marble number is 1, that's just 1, right? So you're going to pick up two numbers out of 6 numbers in an order, okay? One by one. So this applies the principle of counting. This procedure involves 2 steps. Step 1, you pick up one marble out of 6. So there are then there are 6 choices. Then you pick up another marble, second marble from what? How many marbles left? 5. So there are 5 choices. So that is the total number of outcomes, right? Without any restriction. Okay. Okay. So that total 30 different outcomes. Okay. For example, like a 3, 1, 1, 3, you know, that we count them different. Okay. Then we needed to find out all designed outcomes. Right. We were trying to find out, okay, both are odd numbers. So that means you're only going to, the restriction is going to be all the numbers are odd numbers. So you only pick up numbers from the group of odd numbers, which are just 3 odd numbers here. Right? So the same idea, but this time you only have 3 choices, the first step. So 3. Then 2 other numbers left. There'll be only 2 choices. Okay. So that is the number of all paths, all design, all counts with the restriction. And then the probability. Okay. If you randomly pick up 2 marbles one by one, what is the probability? Okay, to get both other marbles, other number marbles, is going to be the ratio. Okay, so 3 times 2, 6 times 5, so that's 1 over 5. Okay, so that's 1 over 5. Okay. So this is how do we? This is a typical example. You know, this is a problem we did in my basic math class. Okay, that's the last 2 chapters about probabilities. Okay. Okay. Yeah, of course we're going to study a little bit more complicated problems. All right. All right, so let's take a look at the next one. 2 distinct fractions are chosen randomly from the set of 4 fractions. All right. What is the probability that the sum is less than 1? Okay. Well, you're going to pick, the order doesn't matter, right? The order doesn't matter, right? So first of all, you have to figure out the number of all possible outcomes. You're going to select the 2 numbers. So the number of all possible outcomes, okay, is going to be just pick up 2 numbers. We don't count their order, okay, and how many possible pairs of numbers you can get. Well, by the formula, see here we're using the count, right? By the formula, this is going to be 4 factorial divided by 2 factorial and 4 minus 2 factorial. Okay, so it's going to be 4 factorial is 1 times 2 times 3 times 4. Here's 1 times 2, here's 1 times 2 because 4 minus 3 is 2. So that is going to be 6. Okay, that is going to be 6. So only 6 possible outcomes. Right, the next step is just trying to find out the sum of which pair of numbers is going to be less than 1. So all I have to do is just the one, you know, you have 4, right? Here, 1/3, 1 over 5, 7 over 10, and then 5 over 6. So you don't miss any pair. So you look at this one. So 1/3 plus 1/5 is less than 1. Then 1/3 plus 7 over 10. Quickly, you can see that this is going to be greater than 1. Okay. Then 1/3 plus 5 over 6, right? And that is going to be, right? And the 6 plus 15, right? 6 plus 15. And this is definitely greater than 1. Okay. Then you look at this 2. Okay. This is actually less than 1. 50. 10 plus 35. Yeah, it's less than 50. Okay. Well, then this 2, right? And this is clearly is greater than 1. Okay. And then finally, 7 over 10 plus 5 over 6 is greater than 1. So the answer is you only have two of them. So the probability is going to be 2 over 6, which is 1/3. Okay, that's how to get. Well, fortunately, we only have 4 numbers here to get, so it's easy to figure out which one has a sum less than 1. Okay. Okay. Now I wanted to think about the next one. Yeah, after we refresh the memory of our probability. A bag contains 5 red marbles, 7 green marbles. Okay, David draws out 2 marbles at the same time. You can say one by one. Okay, what is the probability that they are both red? Right, so go ahead to think about. Why is the total number of possible outcomes is 6, not 24? That's a good question. I'm talking about when we pick up 2 fractions, okay? So we don't count their order. So select 2, how many pairs of numbers, and that's the standard formula. Okay, if I pick up 2 numbers, put them in order one by one, then that would be different answers, right? So first of all, you have 4 choices, right? Then then you have a 2, so you never get 24. Okay, then you have 3 choices. Yeah, that's still just 12 if you count the order. Okay. Okay, I don't know how they get 24. Okay. Okay, so it depends on how do you count them, right? Sometimes you only consider, you don't consider the order. So then you have to use if you don't consider the order, then use this. There's a formula here, okay? N factorial divided by 2 factorial divided by n minus k factorial. Okay, but if you count the order, then you don't divide the k factorial. Yeah, because when you rearrange the k numbers, you get different outcomes. Oh, you said 4 factorial. Well, I do not arrange those 4 numbers. We only pick up 2 numbers here. Okay, we only have 2 numbers, 2 distinct fractions are randomly chosen randomly from the set. Okay, this is different from 4 fact. Yeah, if I say put 4 numbers in the order in a row, how many possible outcomes? Yes, that's 4 factorial, many outcomes. Okay, but I do not put 4 numbers in a row. I only put 2 now, 2 in a row. Those 2 are selected from this group of 4. Okay, even not in a row, I just put it in the hands. The order does not count. Okay, so I have to divide by 2 factorial. Okay, that's how we end up with 6. Okay, yeah, read the question carefully. There's 2 distinct fractions are selected. All right, so the next problem. Yeah, please focus on the next problem. Okay, a bag contains 5 red marbles. Okay, 5 red marbles, 7 green marbles. Right, those are, right. David draws out 2 marbles at the same time. So that means we don't count their order. We put the 2 marbles in your hands. We don't say which one is first. What is the probability that both are red? Right, you open your hands, you grab 2, right? Closing eyes, grab 2 marbles, and then you open your hand. Then you question what is the probability, right, that both are red. Right, so think about this problem. This is a typical problem in probability. Okay, so I hope you got William gave me the answer. Good job. Okay. Is William? Yeah, I think William's answer is correct. Anybody else? Who are here right now? Some students still on vacation. Okay, I have a. Okay, we have a Daniel Lee. I have another Daniel supposed to be here. It's not here today. Okay, Nancy. Okay, Tony. Yeah. Okay, Nancy, your answer is wrong. Okay. Yeah, please. I remember there's another one called Daniel Jiao, right? It's not here. All right, so take a look at this problem. Okay, first of all, how many marbles there? 5 plus 7, right? 12. Okay, 12. So the number, if we grab 2 marbles, the number of all possible outcomes. Okay, we assume that those marbles are different. Okay, just color, there's 5 are identical colors as I have 7 colors. But then marble itself can be different marbles. Just like a 5 Chinese, 7 Americans, right? You randomly pick up call two people, right? Yeah, what is the probability that both are Chinese, for example? Okay, so then those Chinese are different. They're not identical Chinese, but they're Chinese, Okay, so marbles are different, but there are 5 red marbles, 7 green marbles. So the number of all possible outcomes, you have 12 different marbles here. Okay, if you draw 2 out of 12, and do not count their order. So it's like similar to the problems you select 2 students to form a team out of 12 students. So there's a standard formula, it's 12 factorial divided by 2 factorial and 12 minus 2 factorial. So after you simplify, this is 12 factorial. Here's 2 factorial, 10 factorial. And 12 factorial is 10 factorial, 11, 12, and 2 factorial is 2, 10 factorial. 10 factorial canceled out. So the answer here is 66. Okay? There's nothing to do with 36. Yeah, I saw somebody put 36 there. So 66. Now, the number of all designed outcomes. What do you want to get? You want to get both are red. That means you only pick up marbles from the subgroup red group of group red marbles. So that how many red marbles there? 5 red marbles. Okay, you're going to pick up 2. And then 5 minus 2 is 3, right? So after you simplify it, I get 10. Because here's a 5 factorial, 2 factorial, 3 factorial. So 5 factorial, 3 factorial, 4 and 5, and 2 and 3 factorial, and cancel, and then you get 10. Okay, so that is, once you figure out the both, then the probability is going to be 10 over 66. And you try to simplify it, and then get 5 over 33. 5 over 33. Okay, not everybody got the right answer. William did a good job in this time, right? But that's okay. So you understand what I'm doing here, right? And figure out why you get different answers. Which step? Nansen Zhang, I know probably you both did it wrong, yeah? Probably you did not get the right answer for the number of all possible outcomes. And also the number of all design outcomes. Because you want to get, yeah, yes or no? Okay. Oh, Nancy, you got this, after you simplify, you got this. So possibly, yeah, you, some students that count as order. Okay, so yeah, sometimes they count as order. Then the numerator denominator will be slightly different. Okay, if you count as order, the numerator denominator is slightly different. Okay, but then the ratio is still the same. You can grab marble one. You can pick up a marble one by one without replacement. Then you ask, what is the probability that both are red marbles? The answer is still same. So what is different is the numerator denominator will be both different because you count the order. You have the first marble, second marble, right? Yeah. Then the quotient still the same. Okay. If you want to find the probability that all the marbles are red. Okay. All right. So next problem, Christine has 5 different pairs of earrings. What is the probability that 2 randomly selected earrings will be a matching pair? Now here's the point. Okay, 1 little box contains 1 ring. Okay, so total you have 10 rings there, but you don't see them. They're all those boxes are all the same box. Okay, you cannot see it. So you randomly pick up 2 boxes, and you open it. And what is the probability that those 2 rings are matching? Okay. Yeah, please work on this problem. Okay. Okay, anyone has answers now? I see Nathan has the right answer this time. Good job, Nathan. William, double check your work. Okay. So you have a 10 box, right? 1, 2, 3, 4, 5. You don't know which 2 boxes give you a matching pairs. Okay. So the number of all outcomes is going to be what? You pick up a pair of boxes, right? We don't count the order. Okay, right? It's not necessary to count the order. All possible outcomes. That means the number of the pairs of the boxes is going to be 10 factorial, right? Divided by 2 factorial. 10 minus 2 factorial. That's a standard formula. Right? So after you simplify it, 10 factorial is 8 factorial, 9, 10, here's 2, 8 factorial, cancelled, and the 10 divided by 5, 2 is 5, it's 45. Okay, yeah. So the number for design outcomes, there is no need to context the number of design outcomes. What do we want? We want to matching pairs. But how many matching pairs? 5 matching pairs, right? Because, right, 5 matching pairs, right? There's no need even to count. So the probability is going to be 5 over 45. That's 1 over 9. Yeah, William's second answer is correct. Right? Harry, now how did you get 2? You have a 10 pairs of matching pairs? Oh, I know what's going on, I guess. Yeah, you probably do not divide by 2 here. You get 90 for the numerator. Oh, no, I don't know how to get a 2 on the numerator. Yeah. Right? Yeah, you have to figure out the reason, you know. You have to know why you put 2 there, right? There's no 10 matching pairs. There are 10 rings, but only 5 matching pairs. Right. All right, great. So now let's look at problem number 5. We randomly select 6 prime numbers without replacement from the first 19 prime numbers. Wow, what is the probability that the sum of the select numbers is odd? The sum of the selected numbers is odd. So there is a tricky here. 19 prime numbers. Prime numbers, okay? The prime numbers, prime numbers are all odd numbers, except the first one, right? So let's say 2, right? 3, 5, 7, 11, 13. Now, most of them are, except for the first one, they are prime odd numbers, right? So 19, if the sum of 19 odd numbers, right, then that will be, because 19 is odd number too, right? So that is going to be odd number, okay? Okay, think about that. Yeah, we're going to select the 6 prime numbers, not 19, 6 prime numbers. 6 prime numbers out of 19, first 19 prime numbers. The sum must be odd, right? So first of all, you found out the number of all possible outcomes. Right. Okay. So anyone has answers now? All right. First of all, you have 19 prime numbers. You don't need to list all of them, in my opinion. Okay. Right. There's no need to list all of them. So the number for all possible outcomes. Okay. You have 19 prime numbers. Don't waste time to write down all of them. I just write a few of them at the very beginning. So you want to select them one by one. Now I'm going to be careful, right? So you can put them in the order or without the order. What do you think? Okay. So look at that. Randomly select 6 prime numbers. Sounds like there is no, you don't need to count that order. Okay. So so you select the 6 out of 19. Okay. Select 6 out of 19. And that is going to be what? Okay. Now you can also put them in order. Okay. If you put them in the order, then yeah, let's assume it without order. Okay. So that's going to be 19 factorial, 6 factorial. 19 minus 6 is going to be 13. Okay. So this is the number of all possible outcomes. Now the sum of the 6 other numbers is odd, then one of them must be 2. Okay. 2 is there. It cannot change. Okay, because if they're all other numbers, the sum will be even. So 2 must be select. So you pick up a 2 first, no choice. So the number of designed outcomes. Okay. The number of design outcomes is going to be what? All you have to do is just select. You select 5 out of 18 marbles, right? Because one of them must be 2, so it's already taken out. Okay, right? And then all you have to do is grab as a 5. So 18 over 5 factorial, then this still be 13 factorial. Okay. Right? And then the probability, let's simplify it. The denominator is 19 factorial, 6 factorial, 13 factorial. Here's 18 factorial, 5 factorial, 13 factorial. And I'm going to turn this upside down. Right? This 6 factorial, 13 factorial, 19 factorial. So 6, 13, 13 cancelled out. And the 6 is on the top. I have a 6 over 5 factorial. That's just 6. 6 over 19 is going to be the answer. Who got 6 over 19? I did not see any. Right. Now you can also count the order. If you count the order, then be careful. You have to tell me which position 2 shows up, right? Maybe the second marble is 2, or maybe the third marble is 2. A little bit more complicated. So if you don't count the order, just grab the 6 marbles. Okay, the number of all possible outcomes will be, that's by the standard formula, 19 factorial over 6 factorial over 13 factorial. Then you only consider those prime numbers, prime numbers. The sum is going to be an odd number. So one of them must be 2. So 2 is fixed. Don't even think about their options here. So all I have to do is to take 5 prime numbers from from remaining prime numbers from 3 to, right, whatever the last one. Okay, so that's why this should be the formula. Okay. Okay. So the answer is going to be, is this, yeah, this probably different, right? Now, now there's a similar problem you can think about. I'm going to maybe do a little bit late. So if you have a 7 red marbles, 10 green marbles, okay, you want to take 6 marbles out. Now, what is the probability? 3 of them are red, 3 of them are green. You know, this is it's a same type of problems, right? So maybe we will do this a little bit later. Yeah, maybe next class. Yeah. All right. So there are 6. There are many equal numbers of pennies, nickels, the dimes, and the quarters in a bag. So there are lots of pennies there. Okay, lots of nickels. Now, what is probably that the combined value of the 4 coins randomly selected with replacement, be careful with replacement, will be 41 cents. So that means you just write down the 4 numbers, okay? So, but you can repeatedly write down the same number, okay? Right? You can say 5, right? But write down 4 numbers and such that the sum is going to be 41, okay? The choice for a number is going to be, right? It's going to be, this is the point. So 1 cent, right? And the 5 cents, 10 cents, right? Nickel, dime, quarters, 25 cents. And you're going to randomly pick up 4 numbers. Okay, it can be repeated, it can be 111, right? But then, right? Then just only 4 cents here. Right. How do you get 40? 41. I think we add them together. Okay. 1 cent plus 5 cents plus 10 cents plus 25 cents is in 41 cents. Okay. All right. So if you write down 4 numbers, all right, those numbers must be either 1 or 5 or 10 or 25. How many possible outcomes? Okay. How many possible outcomes? I think for the first box, you have 4 choices. For the second box, you have 4 choices. For the third box, you have 4 choices. For the fourth one, you have 4 choices because you can repeatedly pick up the same number from the group of this group 1, 5, 10, 25. So be 4 choices, 4 choices, 4 choices, 4 choices. This is a total number of choices, outcomes. Okay. And that's my hint. Okay. I wish you continue. Now, Nansen gave me the answer. I disagree with the answer. Okay. Try. William, where's William? William, you're beside me. Do you have answers? Yvonne, Lee. Harry, Zhang. right? So the denominator clear, right? Because every time you write down four numbers, but those four numbers can be only 1, 5, 10, or 25. So you write down four numbers. We can repeatedly write down the same number, clear, right? And so the number of all possible outcomes, just like a flip a coin. For the coin, you only have two outcomes for each flip, right? It's H or tail. But here you have four possible numbers you're going to get each time, right? So 4 times 4 times 4 times 4. This is the product is the number of all possible outcomes. Why it's product? Because this procedure involves 4 steps. Each step you have 4 choices. That's why the product of these choices, number of choices, gives you the number of the ways to complete this procedure. All right. Oh, Nansen. Now give me the answer. Pretty close. Good answer. Okay. So now I'm going to figure out the number of desired outcomes. Right? The only way you can get 41 cents is the sum of 1 plus 5 plus 10 plus 25. So that means each type of a penny, a coin must show up once, right? But since we count the order, so that's why we have 4 factorial many different outcomes, design outcomes. It could be 1, 5, 10, 25, could be 10, 5, 1, 25. And so you permutate these 4 numbers, you get the same result. The sum is going to be 41. So now the probability is going to be 4 factorial over 4 to the 4th power. And that's 4 factorial is 3 factorial times 4, right? To the 4th power. Here 3 factorial is 2 times 3. And here's 4 times 4 times 4 here, right? And then the 4 cancels out. So before and the 32. Yeah, 3 over 32. That is correct answer. Okay. This is a probability. Come on, right? By the way, if you have trouble to now we're almost done, right? With well for one more lectures. But I really encourage you to continue in the summer. We're going to go through all those type of probability, number theory, all kind of problems. Okay. And I'm not sure the same time. It's on Sunday morning, not afternoon. Right. So now let's take a look at the next one. Randomly choosing 2 numbers from the set 1, 3, 5, 7, 9 was a replacement. So that means you can repeatedly choose the same number, okay? Or you write down the number, right? And you can use any of those digits. And again. What is the probability that the product is greater than 44? So here 2 numbers. When we're talking the product, right, the order doesn't matter. So when I pick up 2 numbers, oh, be careful, yes. We're not against people. We have to do one by one, okay? Because these 2 numbers can be identical. Right. So you just write down 2 numbers. One, and could be 1, could be also 1, right? So the number of all possible outcomes is going to be, for the first box you have 5 choices, right? For the second box you also have 5 choices. So total you have 25 outcomes. The difficult part, of course, is the number of design outcomes. But clearly 1 plus 1 is 1 times 1 is not going to be greater than 44. Right? So let's write down these numbers, right? So anyone can figure out the numerate? All right. Let's see. Nelson gave me the answer 6/25. I think that's correct. Why nobody else give me the answers? If you get one, please show to me. So I know you're doing the problems. Okay, even if it's wrong, it's fine because I see it. Okay, don't be shy. Okay. All right. So what are you gonna do is you just just quickly look at the possible products. Okay, and the things here is all this counted. So you have to check which product gives you more than greater than 44. So 5 times 9 actually, right, is 9 times 5, which is going to be 45. That's continued, right? And 7 times 7, which is going to be 49, great. And then 7 times 9 is 9 times 7, and that's 63. And also 9 times 9 is 81. Okay. So how many of them there? 6. 1, 2, 3, 4, 5, 6. So the number of desired outcomes is going to be 6. So the probability is 6/25. Great job. Okay. Okay. So now let's take a look at the next one. Okay. A digit is randomly selected from the set. What is the probability that the number 8,400 blah blah 4 is divisible by 4? Write your answer as a common fraction. Okay, I think the denominator is a 10, right? You just need to know just find the digits such that 8,400 D4 is divisible by 4, okay? Just find that such that, right? Such that 8404 is divisible by 4, right? So how do you determine? Yeah. Can you quickly, how do you check whether it's divisible by 4? Right? Anyone has answers now? All right, great. Daniel, your answer is correct. Good job. Okay, so to check whether this number is divisible by 4, and you should know that 100 is divisible by 4, all you have to check is whether this two-digit number is divisible by 4. Right? Right? This two-digit number is divisible by 4. And I think clearly it can be 0, it can be 1, not 2 years, and 4 years, 6 years, 8 years. Okay? So total you have 5 numbers. Okay? So the answer, you have 5 choices. You make this integer divisible by 4. So probability is, here's 5, and you have 10 choices. 10 choices without any restriction. Okay? So there are 10 digits there. So the answer is 1 over 2. Good job. Okay? Okay, how about the next one? In a bag, there are only red and white marbles. The probability of choosing a red marble is 3 over 5. The probability of choosing 2 red marbles without replacement is 3 over 10. How many red marbles are in the bag? Well, you can figure out how many, right? So total, yeah, this we can say n is the number of marbles, and I is going to be the number of red marbles, right? So to determine, okay, the probability choosing a red marbles is going to be R over n, right? That's going to be 3 over 5, but does not mean I is 3. After you simplify it, it's 3 over 5, right? Now, if you select 2 marbles, both are red, what is the probability? If you have n marbles, right? So the probability to select 2 marbles, both are red, 1 by 1, right? Because without replacement, you can pick up 1 by 1 without replacement. So how many, right? So you have, this is there's 2 marbles here. The first one you have n choices. Second one you have n minus 1 choices. Okay, that's the denominator. That's the number of all possible outcomes. Then you only consider red marbles. The first one you have R choices. Second one is R minus 1 choices. So this quotient is going to be the probability of getting both red marbles. So that should be 10, 3 over 10. So here you are solving we are solving as two equations, okay? But R over n is going to be 3 over 5. So it's R minus 1 over n minus 1 is going to be 3 over 10. And divided by 5 over 3, it's 1 over 2. Okay, so I'm going to get, okay, we're going to have two equations. So I is going to be 3 over 5n, that's first equation. R minus 1 is going to be 1/2 n minus 1. So we are looking for white marbles. Well, if you white marbles, if you figure out red marbles, then you get white marbles. So from here, you should be able to solve for I and n, okay? And without much, can we do that? I think we should be able to solve it, right? So you multiply this out. I'm going to find the n first. So by the first equation, it's be 3 over 5 n minus 1 equals 1/2 of n minus 1/2. So I'm going to move this term to the left. And then 1 to the right-hand side, it's just 1 minus 1/2, it's 1/2. Okay, so combine them, it's going to be 10, right? So n is going to be 5. If n is a 5, then I is going to be 3 over 5 times 5, which is 3. Right? If I is 3 is a white marbles, it's going to be 5 minus 3, it's 2. Okay, great. So we solve the problem. At the end, I decided not going to talk about this problem. I'm going to talk about, oh yeah, this is a problem. Yeah, I can talk. Yeah, the last problem. Okay, if a positive 2-digit integer with a distinct digit is randomly select, what is the probability that the number is multiple of 5? Okay. Now to solve this, right? First of all, you have to figure out positive 2-digit numbers, how many of them, right? You're going to select the with a distinct digit. You're going to select them from that group, okay? From that group with distinct digits, okay? So we have the number of all 2-digit integer, okay, with distinct digits. It's already there's a restriction there, okay? So the digits can be from 0 to 9, but the first digit cannot be 0. So you have 9 choices. Then, because the digits cannot be the same, so one digit is already selected, which is not equal to 0. That's okay. Then there are 9 digits left. You can choose one of the 9. So you have 9. So it's actually the 21 such digits, such integers there. Okay. Now, divisible, a number divided by 9 if only if, okay, n is divisible by 9 if only if that last digits must be 0 or 5. So either 0, okay, or 5, right? Right? So question is, how many of such digits there? Well, so the number of designed outcomes, which is the number of digits which are multiple of 5, but still they're different digits, right? First of all, from this group, how many choices do you have? From 1 to 9, right? 9, 0, 1, 0, right? 20, 20, 10, 20, 90. And from here, I cannot put the 0 there front, right? Any digit, but I cannot put the 5 there. So delete the 0 and delete the 5. You only have 8 choices. That's why 17. Okay. So the answer is 17 over 81. That will be the answer. Yeah, Nancy, good job. Okay. So I stop here. We did a 10 problem. Normally it's 10 problems. Sometimes I do, if I do not give enough time then to think about, then I can finish more than 12 problems. But I decided to slow down a little bit. Okay. So we are going to have one more class on probability, and we're done.